Earth feels ancient. But beside the universe, our planet is surprisingly young.
Earth is about 4.54 billion years old. The universe is roughly 13.8 billion.
That makes the universe just over 3 times older than our entire planet. For nearly 2/3 of cosmic history, Earth did not even exist. So what happened during those billions of years before our world was born?
Through the lens, the cosmos reveals its secrets. We are seeing the birth of stars within the Orion Nebula.
Our timeline begins about 13.8 billion years ago with the early universe. The young universe was intensely hot, dense, and completely unlike the cosmos today. Within minutes, conditions allowed the first light atomic nuclei to form. Expansion continued, stretching space itself, while the universe steadily cooled. About 380,000 years later, electrons finally joined nuclei to form neutral atoms. Light could now travel freely across space, creating the cosmic microwave background we detect today. This ancient radiation acts almost like a baby picture of the universe.
Utilizing precise measurements of cosmic expansion, we reconstruct the universe's history, revealing the intricate cosmic web that binds us all.
Those measurements lead to the standard estimate, about 13.8 billion years. But Earth was still billions of years away from appearing. After the first light faded, the cosmos entered a period known as the Dark Ages. Eventually, gravity gathered gas into the first generations of stars. Stars collected into early galaxies, and cosmic structure became increasingly complex. Generation after generation of stars lived, changed, and enriched their surroundings. And both clocks are still running. Earth and the universe become older every second. Inside stars, fusion created many elements that the early universe lacked. Our sun itself is only about halfway through the typical lifetime of a star like it. Massive stars also helped scatter newly created elements back into space when they died.
NASA estimates the Sun has roughly another 5 billion years before its final evolutionary stages.
Over billions of years, galaxies evolved, and the Milky Way took shape. Eventually, the Sun will expand into a red giant, radically changing the inner solar system. Old stellar material was repeatedly recycled into new stars, planets, and dust clouds. Even then, the universe itself will be billions of years older than your is today. More than 9 billion years passed after the Big Bang before Earth began forming. So which is older, Earth or the universe? The answer is not even close. About 4.6 billion years ago, a cloud of gas and dust began collapsing. The universe is about 13.8 billion years old, roughly 3 times Earth's age. Gravity pulled material inward, creating a rapidly rotating protoplanetary disk.
Earth formed roughly 4.54 billion years ago, long after stars and galaxies already existed.
At its center, our young sun formed and began illuminating the surrounding disk. Our planet is ancient to us, but surprisingly young when measured on the cosmic clock. Within that disk, countless grains collided and gradually assembled into larger bodies. And that enormous difference reminds us just how small our chapter of cosmic history really is. Those growing bodies eventually became the planets, moons, asteroids, and other objects we know. Among them was a hot, young, rocky world that would become Earth. Early Earth was violent, hot, and constantly reshaped by impacts and internal activity. Over immense spans of time, its surface cooled, and the planet continued evolving. But Earth's earliest history created a problem. Much of its oldest crust was recycled. Instead, meteorites preserve material dating back to the formation of the solar system. Radioactive isotopes behave like natural clocks, changing at predictable rates over time. Lead and uranium isotope measurements provide some of the strongest evidence for Earth's age. The result is about 4.54 billion years, with an uncertainty of roughly 50 million years. Now the comparison becomes astonishing: 13.8 billion years versus only 4.54 billion.
Earth's entire existence equals only about 1/3 of the universe's current age.
When Earth formed, roughly 2/3 of today's cosmic history had already happened. Imagine compressing all 13.8 billion years into a single 24-hour day. On that scale, Earth would not appear until around 4-6 in the afternoon. Everything Earth has ever experienced would fit into only the final 8 hours or so. Yet even Earth itself remained lifeless during part of its earliest history. Evidence suggests microscopic life was present billions of years ago. Much later, photosynthetic microbes helped transform Earth's atmosphere by releasing oxygen. Complex ecosystems arrived extraordinarily late when measured against the age of the universe.
Dinosaurs, mammals, and humans occupy only tiny fractions of this enormous timeline.
Human civilization is barely a visible sliver, even on Earth's own 4 billion-year history. Long before Earth existed, stars had already been shining throughout the cosmos for billions of years.
That means much of the material inside Earth has a history older than Earth itself.
Many heavier elements in our planet were forged by earlier generations of stars. Earth is therefore a relatively young planet, assembled from much older cosmic ingredients. Hydrogen traces its origin back even further, to the universe's earliest stages. In a sense, Earth's story began long before Earth itself existed. But age and distance are different ideas when we describe the universe. A universe 13.8 billion years old is not simply a sphere 13.8 billion light-years wide. Cosmic expansion stretches distances, while ancient light spends billions of years traveling toward us. And we cannot directly see the Big Bang itself with ordinary light. The cosmic microwave background shows the universe about 380,000 years after expansion began. Modern telescopes look even deeper into cosmic history by observing extremely distant galaxies. Each discovery helps refine our picture of how the young universe became the cosmos today. But the basic comparison remains overwhelming. Earth appeared very late in cosmic history.